Okay guys, so we're going to go over force and motion again. So this is a subject that we kind of in general as a class didn't do as well on. So we're going to practice interpreting these different graphs and things dealing with velocity and acceleration. So here we're given some data and we're given distance traveled by a car in meters and time in seconds. So when we graph this, we are going to put our distance on our y-axis and our time on our x-axis. And we'll put some numbers here, and this is the general shape of our graph. We have a point at 0, 0, 10 seconds, 20 meters, 20 seconds, 60 meters, 30 seconds, 60 meters, and 40 seconds, 200 meters. So our first question is, given the data above, when is the car moving? So it's going to be moving, if you remember our distance and time, our slope of our line is when it is telling us the velocity. So when it has a velocity, it is going to be moving. So that means we have movement from here, here, and here. So our movement is happening 0 to 10 seconds, 10 to 20 seconds, and 30 to 40 seconds. Our next question, when is the car not moving? So that's going to be where our line is flat. We have a 0 slope because that's telling us our velocity is 0. So this is also telling us that we're at 60 meters, we're still at 60 meters, we're still at 60 meters. Nothing has changed, so our distance is the same. From 20 to 30 seconds, the distance is the same, it's not moving. So here we have another graph. We're given our distance and we're given our time. So the first question, where is the object in this graph on the left not moving? And so it's not moving at 2, because here our graph is flat. Slope is 0, velocity is 0. Next question, where is the speed the greatest? So if you remember, if we're looking at distance versus time, our slope tells us the velocity or speed. So that means when slope's the greatest, speed's going to be the greatest. And that is happening at 3. We have the steepest slope. Okay, so now we have another graph. This time, though, we are given speed and time that we are graphing. So here are the data points. We have a point at 0, 0, 10 seconds, 30 meters per second, 20 seconds, 90 meters per second, 30 seconds, 40 meters per second, and 40 seconds, 40 meters per second. So the first question, given the data in the table, where is the car speeding up? So if you remember, if we have speed or velocity and time, our slope is going to tell us acceleration. And acceleration is when we're speeding up. So it's going to be speeding up when we have a slope that's positive. So that happens from 0 to 10, 10 to 20, and that's it. That's where it's speeding up. Where is it slowing down? So slowing down is when we have a negative acceleration. Our slope is going to be negative. So that's only happening from 20 to 30 seconds. And then where is acceleration? 0. This is happening here. We're still moving. We're just not getting faster or slower. It's going 40 meters per second, still 40 meters per second, still 40 meters per second. Okay, so here we have another graph and we're given speed versus time again. So the first question, what does the slope of the line from B to C mean? B to C is right here. And that's telling us it's moving at a constant speed. We're going at 30 meters per second, still 30 meters per second, still 30 meters per second. But it is moving. It's just not speeding up or slowing down. Next question, what is the speed at the start? So at the very beginning, our speed is 10 meters per second. Next question, what is happening from point A to B? So A to B. So this is speeding up. We're speeding up, and we know this because it has a positive slope. Speed and time, or velocity and time, is going our slope is going to be acceleration. That's how we know it's speeding up. Last question, what is happening from C to D? How do you know? And this one, it's slowing down, and this is because our slope is negative. Okay, so now we're going to practice looking at some diagrams and telling if the force is balanced or unbalanced and calculating the net force. Okay, so in this one, we can look at it and figure out that this is going to be unbalanced because they're not the same, they're not equal and opposite. And our net force is going to go to the right, and it's going to go to the right 3 newtons. And we figured that out because these are opposite. We do 10 newtons minus our 7 newtons to give us 3 newtons. Okay, what about this one? So this one is also unbalanced. And this one we're going to go to the left, and we're going to go to the left by 500 newtons because we do 900 newtons minus 400 newtons equals our 500 newtons. Okay, so this is a picture of a beautiful car that I drew. What is the net force of this one? First of all, this one is unbalanced again. And we are going to actually add our forces for our net force. So this one has a net force of 700 newtons because these are both going in the same direction. We do 500 newtons plus 200 newtons give us 700 newtons. Okay, what about this one? This one is balanced. We have 2 newtons going up and 2 newtons going down. 5 newtons going left, 5 newtons going right. It's balanced. It's not going to be moving. We could also, going back, we could also say that this net force is 0 newtons. Okay, what about this one? Okay, so this one is unbalanced. And this one's a little tricky because it's going to be, the net force is 2 newtons up, but is also going to be 2 newtons to the right because we're not balanced going up and down. We're also not balanced going left and right. Okay, so now we're going to practice identifying Newton's law in different examples again. Okay, so here this man is trying to hit this, it's like a strength demonstration with a mallet, and it hits it and bounces back and hits him in the head. So which Newton's law is this? This is a good example of Newton's third law. And that states for every action there's an equal and opposite reaction. So the action is the man hitting the mallet, and the reaction is it bouncing back up and hitting him in the head. Okay, so this one we've seen several times before. We have the bowling ball and the balloon. So which does this show? This shows Newton's second law, which, remember, is force equals mass times acceleration. So that's telling us if we have a bigger mass, it's going to take a bigger force. Or if we have a bigger mass, it's going to accelerate less. You can think about it either way. So in this case, our bowling ball has a bigger mass, therefore it is going to accelerate slower than the balloon does. Okay, what about this example? Okay, both of these are Newton's third law again. So for every action, there's an equal and opposite reaction. In this first one, the action is the shooting of the water gun, and the reaction is the boy falling over. Similar idea with the second one. Action is shooting the gun, reaction is the recoil. Okay, and this one. So this is Newton's first law. So that states an object in motion stays in motion and an object in rest stays at rest unless acted upon by an unbalanced force. So in this balloon example, the water is at rest, and it's staying at rest until acted upon by a force, and that force is gravity making it fall down. The man in this subway is in motion. His body wants to stay in motion, and that's why he continues to move, making him fall over. But remember, it's an object in motion stays in motion unless acted upon by an unbalanced force. And in this case, we do have a force, and that is the friction on the ground keeping his shoes from moving. Okay, and then a reminder, what is inertia? Inertia is the resistance to change. So that is Newton's first law. So, and it's also related to its mass. So which is going to have more inertia? Which one's going to resist change more, a bowling ball or a golf ball? So this one's going to be, a bowling ball has more inertia. It's going to take more energy, more force to move it if it's stopped. It's also going to take more force to stop it if it is already moving.